This is Miss Morel and another fabulous, exciting video on looking at three-dimensional figures. And today, you guessed it, we are going to be looking at finding the surface area of prisms and pyramids. And this lesson, we're just going to talk about what exactly is a prism and what exactly is a pyramid. How are they different? How are they the same? And you can see here I've just Googled, you can kind of see over here I've got prisms and pyramids, and again a plethora of information comes up when I put this just into the Google Drive search engine. So lots of different images to look at. Some of those are helpful and some of them might not be. So let's first look at prisms and pyramids. So when I'm talking about a prism, okay, I need to have two congruent bases, okay, and that might be lots of different things in that situation. For example, this figure right here would be called a rectangular prism. Okay, so I need to have two congruent bases, and then all of the other sides are made from rectangles. All right, so this is a rectangular prism. I could have called these two the bases as well, but they're calling those two, and then the other four are made up of rectangles. This one right here would be called a triangular prism because the two bases, okay, are triangles, and then the other three pieces are made up of rectangles. So we could have prisms that are hexagonal prisms, we could have octagonal prisms, we could have a 100-sided polygon prism. So if it was 100-sided, the two bases would be 100-sided polygons, and all of those other faces would be made up of rectangles. Now a pyramid, I know that when I say the word pyramid, you're able to visualize a pyramid. Maybe you've even seen pictures of the Egyptian pyramids or the Mayan pyramids. And a pyramid has one base, and then the other sides or the other faces are made up of triangles, and they always meet up at one point at the very top, which is called the vertex point. So this pyramid right here has kind of a strange name because the base is a square. This would be called a square pyramid. If the base was a rectangle, it would be called a rectangular pyramid. All right, so just going back and looking at, again, here's some pictures of pyramids. You can see that the base in this one looks to be a hexagon. That would be called a hexagonal pyramid. Over here, this looks to have a hexagonal base. This would be called a hexagonal prism. All right, so lots of different pictures. You can Google this, of course, on your own and see lots of examples. All right, so let's look at how do I find the surface area. So I want to find the area of all of the pieces that are making up, in this case, a rectangular prism. I don't have any dimensions. I would need to have that. Now I know that this looks like a square. I'm going to go ahead and say that. I'm going to say that this length is 5. And I'm going to say that this is 6. And I'm going to say that this length up here is 7. Okay. So the first thing I want to do then is see how many pieces are there here in this surface area. So I'm noticing that if I were to take this apart, I'm going to have these two pieces, the one that's 6 by 5 and the one behind it that's 6 by 5. I'm going to have, so I'm going to just go ahead and kind of highlight a couple of things here. So I'm going to have those two pieces that I just mentioned. I would also have this piece, right, and this piece over here. Those two are going to match up. And I would also have this top piece here is going to match up with that bottom piece. So it looks like I have a total of 6 pieces for my surface area. So how would I find my surface area? I'm going to go ahead and abbreviate it, surface area. And I'm going to first find that front piece, which would be 5 times 6. And there's 2 of those, so I'm going to do 2 times, and I'm going to put 5 times 6 plus, I'm going to do the two top pieces. So I'll have 2 times, the top piece looks to be 7, and this length right here is 5. Plus, and I need to do those two side pieces. So this piece right here is going to be 6 times 7, and I'm going to have 2 of those. So 2 and then 6 times 7. Okay, and then I'm going to go back and just simplify that. So my surface area is going to be again, surface area is going to be 2 times 5 times 6, so that's going to be 2 times 30, which is 60. And then that's going to be 2 times 7 times 5, that's going to be 35 times 2, that's 70. I'm going to have 2 times 6 times 7, so that's going to be 42 times 2, that's 84. And then the last thing I'm going to do is just add those up. So it looks like I have 60 plus 70 plus 84, and that's 214. And I did not put what the units would be, but they would be square units. So if I was using inches, I would put inches squared. If it was meters, I would put meters squared. Okay, so that's finding the surface area of a rectangular prism. All right, let's look at a triangular prism. So again, it's called a triangular prism because these two bases, okay, this base and the one over here are triangles. So it looks like I'm going to have 2 triangles, and then I have 1, 2, 3 rectangles. So there's a total of 5 pieces, okay, in this surface area. So I'm going to just first go ahead and put, so my surface area is going to be 2 times whatever those triangles are, which I'm just going to put base times height divided by 2. Oops, I don't want a z there, I want a 2. Hold on a second. Okay, yeah, base times height divided by 2 plus, oops, a little bit of technical issues here, they're good, plus whatever those 3 rectangles are. So that's going to again just be a base times height plus a base times height plus a base times height. So I'm just going to put right there the 3 rectangles. Okay, so that's kind of my general formula I'm going to use. Now before I can actually find these, I'm going to need to know what some of these values are. So I'm just going to say that this length is 3. Hold on, let me change that color. I'm going to, oops, I didn't want to do that. Hold on. Okay, great, got it back. All right, so I'm just going to go ahead and put that this length is 3, and I'm going to put that this length is 4, and I'm going to put that this length over here is 10. Okay, and I'm also going to say that this is a right angle. Now, I would either be told that in the picture, or I would be telling, you would be told that that's a right angle. All right, so let's find the surface area. I'm going to start with finding the area of this triangle. So since this is a right angle, this is my base, this is the height. So I'm going to go ahead and find my surface area is going to be 3 times, now there's 2 of those, so don't forget that. I'm going to have 2 times, and then it's going to be 3 times 4, which is 12, but then I'm going to divide that by 2. Again, I'm following that formula up above, base times height divided by 2. So that's 12 divided by 2, which is 6. So I'm going to put 6 there. Okay, and that's finding the area of that 6 is the area of this one triangle, and I'm timesing by 2, that's giving me the one behind. Okay, now I'm going to put a plus. All right, now I need to find each of those rectangles. Now I'm going to start with this one, okay, that's kind of hidden behind here. That's got a length of 10, and this length is 4. So that's going to be 4 times 10. So I'm going to have 4 times 10 plus, okay, now I'm going to find the one that's right here that's kind of underneath. Well, that has a length of 3, and this is also a length of, yes, you got it, it's got to be the same as this length here, 10. So this length right here is also 10. So it's going to be 10 times 3. Okay, I got to find that last piece. I got to find this piece that's right here on top. Now, I already have this length. This is 10, but I need this length. So how am I going to find that length? Well, I am given that it's a right triangle. I could use Pythagorean theorem to find, again, what am I trying to find? I need to find this length right here. Okay, that's what I don't know. So I have 10, I'm not sure what that is, so I'm going to just go over here on the side. I'm going to use Pythagorean theorem. Okay, so I'm going to put 3 squared, which is, so I'm going to write that out. I'm going to put 3 squared plus 4 squared equals that question mark squared. Okay, so let me go ahead and do that. That looks to be 9 plus 16, which is 25. So I'm now going to have 25 equals question mark squared. So what would that be? What number squared is 25? That's right, that must be 5. Okay, so this must be 5. Now some of you I know would have remembered we talked about common right triangles back in February, and the very first common right triangle was a 3, 4, 5. So some of you might not have even had to have done Pythagorean theorem to get that. All right, so now I'm going to come back over to here. I'm going to have 5 times 10. That is that last of that rectangle. So again, this is my 2 triangles. This is my 2 triangles. This is one of those rectangles, this is the other, this is the third. Last thing I'm going to do is find my surface area, which is going to be, it looks like 12 plus 40 plus 30 plus 50, and that is going to equal, let me go back and add those all up. I've got 52 plus 80, and that looks to be 80 plus 52, 132. And that again would be considered square units depending upon what units I were to use. All right, I hope that that was helpful. Again, I encourage you to go look. There's lots and lots and lots of resources. In fact, here's a net, okay, representing that rectangular prism. When I do say net, that just refers to if I took the 3-dimensional shape and I were to flatten it out into a 2-dimension, that's called the net, all right? Kind of like the puzzle pieces if I put them together. All right, I hope that that's helpful. Again, if you have any questions, please email me, and I will love to help you.